Hi, my name is Vahan Davoudian. I'm a physics experimentalist for 30 years, and today's topic is unique physics concepts, how to promote the science by Vahan Davoudian, physics experimentalist, and this is my email, vahandavoudian1948 at gmail.com. First of all, I would like to thank YouTube for wonderful opportunities for uploading our science videos, latest technologies, and science concepts. We can connect with many viewers, exchange views, and learn. YouTube is like a huge network and university. I call them synapses in human's brain, connecting billions of neurons to transmit information and charges. YouTube is the key to learn. Many viewers emailed me and loved my science videos. It was great encouragement for me to upload more theories and experiments for physics enthusiasts. My theories and experiments are unique. I have never seen in any physics books. All of them are substantiated with experiment. I have already uploaded 40 theories. You can watch them on YouTube. As a token of appreciation, I would like to thank everyone for supporting me. Your feedback is extremely important. I do honor them. Any suggestion, adding, or any concerns. My inspiration came from sports, nature, animals, and insects. Today I have very important and generous proposal for physics and science lovers. Any college or university want me to come to you, I will be honored. I will pay for all the expenses. I can even bring experiment for demonstration. I have 40 more theories I will be uploading every week. I finished my theories by year 2000. I have had many lectures in physics in Regis, DeVry, and CU Boulder universities for physics students. I will be able to highlight some of them theories because they are 20 hours experiment in laws of physics. And laws of physics, overall, they must be thermodynamically all in closed system, like pendulum. Well, my main objective here is to promote the science and activate the sense of wonder in students and especially the young generation. And when I activate your sense of wonder, what you can do, you can analyze. This is the way I did. And in fact, 6 months ago was my latest theories in 3 parts. It was odd name, How to Learn Laws of Physics in the Streets. And that was great success because most people, they emailed me, they loved that. How could you learn laws of physics in the street? You have to go to college. But I proved that there's so many things, intuitive, counterintuitive, we just ignore them. We can see in our nature. Anyway, I start with the third part, and this is going to be one of 3, or the last part of my lecture. And this is about the positive and negative charges. And like I said, I published this in year 2000, and this was also great success. And this was a positive and negative charges, but the main subject was the theory of separation of charges. Well, why did I do this? Because Andre Ampere is one of the greatest minds in electromagnetism. He had an experiment. I must have read maybe 10, 20 books. They never explained why. When the current is flowing in one direction, they attract each other. When it's the opposite direction, they repel each other. I knew that, it's a separation of charges, but I wasn't sure. Like I said, I've always been observant. With Galileo and Michael Faraday, I always watch the nature. I see exactly what is happening, and then I'm inspired. So I used to live in Denver, Colorado for 20 years, and then they have a huge river, it's called Platte River. And then one time I was walking to have my cup of coffee in Starbucks, and then I just stopped on a bridge, and this was a great moment in my life. I realized that, the current was not so bad, it was just regular, there was no rain, nothing. And then I was standing on the bridge, and then I saw something amazing happen. I just immediately compared the flow of water to the current, and those, all this, leaves, and then everything else floating on the water like electrons. And then I saw something amazing. From my perspective, the water was flowing from north to south, and then I could see some leaves and some other things. They are going clockwise from my perspective, and left side they were going counterclockwise. I wasn't sure. I said, I have to prove this. So I had to go get some wood chips, and then I went up the river like almost half a mile. So that was a lot. And then I spread them on the water. Well, of course they were floating. And then I ran back on the bridge to see what was happening. That's exactly what happened. From my perspective, I was looking down. I could see that those wood chips are going to the right or clockwise, and the left side was going counterclockwise. I said, the mystery is solved. I had to rush home and then finish my theories, and I knew that this was right. Well, of course, I drew something here. You can see. See, this is like a flat river, and like I said, this was so obvious that there was no way I could make a mistake. And then, I just put, these are the electrons, then those are the wood chips. But anyway, this was great success. And like I said, if you watch my theories, you can see this is almost 1.5 hours, and everything is explained with a great precision. And in fact, this one is for the theory of free-falling object. This was also great success. It's 4 parts, and I'm going to show you maybe 2 or 3 posters. But this, everything is explained with a great precision. There is no way that you won't understand. It's just so easy to understand because I explained to the best of my ability, to the best of my knowledge. This is the ramp I made. Let me post it so you can see it. Galileo was an amazing person, and my inspiration for this theory of free falling came from Galileo, and especially Michael Faraday, because both of them, he had to, slow down the speed of light, and Galileo had to slow down the rolling balls or brass balls. That is the way he could find exactly how things work. So Galileo did this, and then he was an amazing scientist, and he solved the problem. How could someone solve the problem with no clock, no laser beam, nothing? All he had was these rolls and ramp like this. But he was so genius, he came up with this Galileo's uniformly accelerated motion, and velocity is equal to acceleration times time, and the distance is half of the acceleration times time squared. And in fact, in this last 30 years, it doesn't mean I don't trust scientists, but I have to, make sure that, I'm happy what they did. Maybe I can improve it. That's exactly what I did. So what I did, my ramp was not like Galileo, what I show you in a minute. My ramp was like a V shape. It was like this. It was like a V shape like this. The reason why I could roll those balls, not only here is the center, I could get their kinetic energy, but I could also tell how far do they go. But anyway, this one is exactly like Galileo's, but I have to prove that the Galileo was right. And like I said, I worked on this probably 9 months. It was not easy. In my car garage in Denver was almost like 20 meters. It was 3-car garage. So I had to have my ramp 10 meters. And I did this with great precision. You can see 1 meter, 2 meters all the way. And then this was not like a laser precision, but it was good. So I had to get a stopwatch, and then it doesn't matter how hard I worked, I could not improve from 1/10 of a second. I consulted with a physicist and a mathematician. They said, "Juan, you're okay. You don't have to get a laser beam." So the best I could do, it was 1/10 of a centimeter. So the height for my ramp was exactly 133 centimeters. I must have repeated this experiment maybe 100 times. I was making sure, I pressed that stopwatch immediately, I don't waste any time, and make sure at the same time I keep my eye on the balls, how far do they go. So Galileo was an amazing person. He discovered that the acceleration increases. It's not the same. I mean, how could you, in 4 seconds, this ball is accelerating 8 meters? Well, of course, I had to solve this problem. Because poor Galileo at that time had no idea what the kinetic energy was. It would take another 200 years, and then Sir Isaac Newton, and after that it was Amélie de Châtelet, came up with this fantastic idea, kinetic energy, and they solved the problem. But Galileo had no idea. But he could prove it that, the rolling ball is accelerating. And the poor man had no clock, nothing. But he was genius. He could do this with a water clock, he could do this with his pulse, but overall, the easier way he did it, this ball was going here, he had some, ring here, like bell here, another bell here. But then he realized, as the time goes by, half of the acceleration is multiplied by itself. Like 2 minutes is going to be 2 times 2, it's going to be 4, so 4 times half is going to be 2 meters. So 3 times 3 is 9, and 9 times half meter is going to be exactly 4.5 meters. So that's why he discovered that this is what happened. So when the time comes in the equation, the kinetic energy picks up. But like I said, he didn't know about the kinetic energy. But what Galileo did was 100% right. So I did this experiment, God knows for how many months, and then I was sure. And then I typed it in. At that time, there was no YouTube. I had to type in. It was just painful. But you can see here, the main concept for this is the gained kinetic energy. Because gravity is not playing any role. And this was my concept. This was my idea that, if the ball is rolling here, it's not going to be the same because it's gaining momentum. The reason why, the time comes in equation. And then the kinetic energy comes in. And then I was going to do like 20 meters, I couldn't, but this 10 meters is more than enough. But in order to follow my master, Mr. Galileo, I had to reduce the acceleration due to gravity 20 times. So the acceleration due to gravity, it was exactly 1 meter per second square. I had to use 150 grams, I had to use 72 grams. After few days I realized 72 grams is the best. So I did that. I had to do another ramp because what Galileo did, he just increased the angle for the incline, decreased the angle for the incline. The proportionality did not change. I said, Vahan, you have to follow Galileo, you have to do the same thing. So this one, the height is 39 centimeters. This is a smaller ramp, but the acceleration due to gravity is 0.5 meter per second. So you can see the first second acceleration is not 0.5 meter, it's exactly 25 centimeters. So after 2 seconds, 2 times 2 is 4, times 25 is, see, 225. So like 4 meters the same way. So all the way, it took exactly 6 seconds for 9 meters versus 4 seconds for 8 meters. And I knew Galileo was absolutely right. It doesn't matter how your incline is. Well, of course, I have to mention something is so important. Free falling using the same formula, half acceleration times time squared. But there's a factor here. When I roll a ball on a ramp, it's more friction. It has to push the air, and at the same time, it's the rail, we got more friction. But the free falling, it doesn't have that much friction. But they follow the same rules. Because I did it on free fall in our warehouse where I used to work, it was 15 meters almost. And then I realized it's exactly the same thing. But unfortunately, I didn't have the strobe photography to take pictures or laser beam. And then I realized this is more than enough for my purpose. And this is another one I show you. This is for free falling, and it doesn't matter how you do it. And like I said in my last theory, like 1 hour ago, I said everything must be thermodynamically enclosed system. But I had to pay $100,000 to get a vacuum. So I said, I'm not going to do that. It doesn't matter. So if you drop a ball, it doesn't matter in air. It has to do with the local gravity, which is we consider is 9.82. See, like 0 meter is 1 second is traveling minus 4.9 meters. In 2 seconds, 2 times 2 is exactly 4, and then 4 times 0.5 is exactly 19.6 meters. And same thing happened, and 3 times 3 is 9, and 9 times 0.5 second is exactly the same. And you can see I also had to calculate the kinetic energy, and the proportionality is 100%. And then I was not happy with this. I had to go in Jupiter, Mars, Moon, and then I realized Moon, the gravity is 6 times less than Earth, but the proportionality is the same. Mars is less, and I mean, all those planets I did, I realized the proportionality is the same. Free falling is following the same concept. And in fact, I have more theories, and one of them is, I mean, I got so many things to explain. It was the Earth's electric field. I have to display some things here so you can see. I do honor the Earth's electric field. They said that, iron core in a Earth, or, nickel iron core, is just having the dynamo effect. Well, I do honor that theory, but I came up with my own theory. It's called electric charges. And then I have a theory, the Earth's electric field. I will demonstrate some of the highlights so you can see how good they are, how comprehensive they are. This part came, my inspiration came from Michael Faraday. I said, okay, Vahan, you theorize that the Earth's electric field, like flux line, are coming and then is going above the Earth and coming back, but how can it happen? So I had to use my own gearbox. The reason why I didn't want to use any electromagnetism, I would ruin everything. But why did I do this? This must be almost like 50,000 turns, and then I had to take apart 2 or 3 huge photocopy machines, and these are the finest I could tell. Well, I said, if I have a relative motion, like the way Michael Faraday did, I will be able to detect that. But I didn't have real good, instruments, so the best thing I could use was the transducer. And this transducer is extremely powerful, and it's so good, it shows almost everything. Let me show you if I can grab something here. See what happened? Because we have alternating current, and that is why this is showing alternating current. And then I said, if I rotate this, I can, I estimated this is going to be 500 RPM. I didn't want to go higher than this because, I need a bigger gearbox, so I made my own gearbox. See, if I rotate this, you can see now I can change it to current. The same thing happened. See, current is better. See what happened? The faster I go, the more induction I get. See? Okay. I have to put this down. I have another one. Like I said, this transducer shows exactly what happened. In fact, my theory was based on this. It's called thermoelectric. Let me put this out, you can see. I did so many experiments. And in fact, this part, I was inspired by Lord Kelvin. He was, or Mr. Thomson, he was a great scientist. One day I was experimenting something in my lab, and his name was Dr. Thomas. And then he had no idea. He had two different metals, and then he heat them up. One was less heat and the other more heat, and then he could detect millivolts. And then he had no idea what that was because he was a doctor. He was not physicist, but he knew about the physics. So he had to go to a Dutch physicist, Hans Christian Ørsted, and then he analyzed everything that, you have two different metals, that's what happened. So you get separation of charges. And then I was thinking about that. I said I can solve this problem. So I had copper and I had iron. So I had to join them. It was like a thick straps, I had to join them. So I bought a torch. I just heat them up like 1,000 degrees Fahrenheit, and then I could detect millivolts. And then I had to go back to Mr. Lord Kelvin, and he solved my problem. I said, well, why this is happening? And then I realized flow of electrons, or mobile electrons, in different metals, they're different. Iron is different, copper is different. Well, of course, I'm not talking about conductivity, but the flow of electrons in iron is away. It's toward it's toward the heat, and in copper is away. So in other words, if you heat up iron, so you can tell it is not getting heated because it has the negative thermoelectric effect, but the copper has positive. So Mr. Seebeck did this, and then I said I can do it also. And this is called the thermoelectric effect. Let me put this on so you can see. Let's see, where did I put that? Okay. I read it for you so you can see. This is the theory of Earth's electric field. The extreme temperature differences between the lower part of the mantle and the Earth's core is a huge difference of potential. Flow of mobile electrons due to thermal energy of outer core toward the colder region creates the separation of charges. We will get the north and south poles. They have to go through the Lorentz forces between the north and south, and deflected consequently undergo the cyclotron motion. And in fact, I was talking about that Mr. Seebeck, and this is the way he did it. Let me post this so you can see. And in our whole life, water heaters and everything else is using this concept. It's like this. Let me show you. It's like this. It's called Seebeck. So you can see here we have like copper, and then we have iron, it could be aluminum. But you know, whenever you measure here, you have the heat difference here, and there's a different heat over here. You can have millivolt. So when we're talking about the Earth, is so different. Earth's core is huge. So the electrons are flowing toward the center of the Earth because of the iron. And in fact, iron, nickel, are the same way. But probably the most thing is iron. But at the same time, they have to flow back. So we have so many different metals in it. And this was my experiment. Then you can see the flow of electrons. See here? This is the heat, this is the iron. It's toward the heat, but in a copper is away. And then I wasn't sure about this. Like I said, I bought a torch, and then I had to get straps like this. Like I said, I had to heat this 1000 degree Fahrenheit. And then I graduated like 5 centimeters on each one, exactly 5 centimeters. So when I measured with my infrared, I had an infrared, let me show you. This is my infrared, and then when I measured, because it's a contactless, when I measured, I realized that, you know, heat is different on this because it's exactly like the other metals. It's not like here you can have more heat, less. So what this means that, you know, iron was different. Let me see if I have the iron over here. Yeah, this is the iron. So iron flow of electrons is toward the heat. So I had the same graduation on iron, like 5 centimeters, and it was exactly the opposite. So I had more heat over here, and it was going toward this. So in other words, the heat concentration was toward the heat, not away from the heat. But in copper, the concentration of the mobile electrons was away from the heat. So in other words, we got like a 190 here, and then hot. I did the same thing with aluminum and some other things, and then I realized that's exactly the same thing. And then I also did something so important. I graduated a huge metal strap like this. It was probably more than 2 meters. And then my compass was showing exactly north and south. And there was no exception. And I have to mention, this strap was never magnetized or anything. It was exactly like normal, iron. It was ferromagnetic. I said, what if I cut this in half? I cut them in half, again was showing north and south. I cut this half. I would do almost 100, as small as maybe 2 inches, and that's what would work. Then I realized this is not enough. And like I said, I used to work in an English company called John Crane, and then it was in historic places called Golden. I said, I have to do this with rails. It was abandoned rails. It was built maybe like 100 years ago, and then they did not use it anyway. I said, I can do that. So I got my compass, I went to the rails. It was exactly the same way. Because for the kinetic energy, the rails are cut a little bit, like almost like 1.5 centimeters, 2 centimeters, so they won't get crooked. So I did this, and this was amazing. I spent almost half a day. I went like 2 miles, up and down, all those rails. I realized rails are ferromagnetic. The same thing happened. So my conclusion was this. All the charges are coming from Earth, and that's what is causing the gravity. So finally I came up with this idea that the entire concept of the gravity is electrostatic charges and electromagnetic charges. Imagine when you have something like this, perpendicular to the earth, the charges are directed 100% or 90 degrees toward the center of the earth. Well, when you tilt that object, it doesn't matter. It can be ferromagnetic, it can be dielectric, it can be wood, it can be branches, it can be anything. So here we have more charges. So that is why it's causing, this falls. But like this, if it's perpendicular, it's not going to fall because the charges are directed 100% toward the center of the earth. And I'm hoping, some scientists will take this into the consideration that, those charges are so important and that's coming from the center of the earth, and then you can tell. Of course, I have to demonstrate Michael Faraday's induction, which was one of the greatest minds in the history of science. And Michael Faraday did something, and then I have to discover something else. But it doesn't matter if the magnet moves or the coil, it doesn't matter, see? It doesn't matter. You get voltage here, and it's directly proportional to the amount of the, how fast this rotates. And then, see, this one is fine wire. This one gets more induction, and the number of turns. And the induction saved our life. And in fact, James Clerk Maxwell has two of the Gauss formula and one Michael Faraday and one for Andre Ampere. So you can see it doesn't matter how you do it, and as long as you have a relative motion can be magnet, can be this, can be pulled and pushed, can be rotation. It doesn't make any difference, so you get induction. So this was for Michael Faraday. In fact, James Clerk Maxwell was amazing scientist. Overall, when the charges accelerate, they become electromagnetic waves. So what it does, they are perpendicular, electric field, magnetic field, electric field, magnetic field. And what James Clerk Maxwell did, he changed our life. He came up with the same speed of light, and then he realized that light is electromagnetic. And I remember one time I was having a speech, in CU Boulder. I came up with this idea. I said, what if I accelerate the Teflon? It had never been done in the history of science. So I had to devise this coil. This is almost like 800 coils. And then I said, what if I have a Teflon like this, and the Teflon is accelerated in this? What will happen? And then my idea worked, because this is a Dremel motor. I can go to 30,000 RPM. So what I did, I'm not going to do now because it takes time anyway. When I did this, 2,000 RPM, it was so low. When I did 5,000, 10,000, and 20,000 RPM, exactly like a live wire I showed you a few minutes ago, I could detect almost 5 meters away. 5 meters away. Then I realized when the Teflon is accelerated, the same thing happened. How could you get like a live wire that this will detect exactly electromagnetic wave? So this is the way I did it, and in fact I'm happy. This is also new concept. It's called new concept, how to get induction without magnetic field. I have another one here, but I have to explain about the electronegativity because this concept is so amazing. So I made this gearbox so you can see. Okay, so you can see this gearbox. And this is like a Teflon, but look here. See, when it rotates, did you see what happened? See, the faster I rotate, the more induction I get. Well, of course, this is not a good gearbox. I had gearbox before, it was going like 4,000 RPM. I could get from almost like, half a meters away, but this one goes like 20, see? Okay, let's put this down. This was another concept, and then Michael Faraday was genius. Well, of course, his coil was not like this. It was just a rod, iron rod, but I had to enhance it a little bit. So Michael Faraday did this, but I don't know why that genius mind, how could he think about that? So he had some, wires here, I have no idea how many turns, and then there was another one, and they were not connected. So what he did, he connected this to 12 volts DC, and then this was connected to his voltmeter. At that time there was no digital, everything is analog anyway. So he was not getting induction, and all of a sudden he remembered, if he cuts this on and off, the DC voltage, because when you cut off something, magnetic change is changing. Magnetic field is changing. And unfortunately, nobody explained about Michael Faraday's experiment. I had to do this in Sioux Boulder. They love this idea. I said the reason why, when you pull the magnet in, and then you pull it out, when you pull the coil in and then pull it out, it's half of the circle, half of the sine wave. Then the other half is minus. That's why. And what Michael Faraday did, the poor man had no idea. He discovered the alternating current, but nobody knew about that because he didn't have, college education, and nobody even told him. We didn't have to wait for Tesla another 60 years. And then I had to solve this problem that, it was alternating current, what Michael Faraday did. It doesn't matter, you push your magnet or you rotate your magnet, it's the same way. So I had to improve his idea. I said, what if I made my own gear? So instead of going back and forth and then doing with my finger, this is going to be much better because I think this is 36 notches. No, 26 notches. So what I did, see, I connect here, one side minus or plus, it doesn't matter, and the other one was here. So you can see underneath. And then what it does, as I was rotating this, it was cutting on and off, it was much faster. And to my surprise, I had to do one induction motor from my bathroom. Let me see where that is. Well, it doesn't matter. I had a small bathroom, induction. It was not going fast, but it was rotating. So by cutting on and off the DC voltage, you can also have alternating. And this was also good. People love this idea that, I came up with this gear. This gear could have been much bigger. I remember in the year 2000, I had a huge one by metal, but unfortunately I lost it. So I had to make my own wooden gear. So the induction, you see what happened? It's exactly the same way. It depends on, so on and off, on and off. And imagine with the DC, we could not even survive. The reason why we get induction because of changing magnetic field. You have your shaver, you have your toothpaste, you have everything, the toothbrush and everything else. You have to do it with alternating current. Okay, I have two more. That is extremely important because you get this down, you can see. Of course, the background is so busy, I have to have something white so it won't blend in. Let me get this. So probably this is the most important experiment in my life, and that is a little bit complicated. I have to explain this. I came up with this fantastic idea. Albert Einstein called this principle of equivalence. It's a misconception always when we're talking about mass, when we're talking about weight. Sometimes people are confused. And always I remember I had it in my science lab, the mass is different and weight is different. The 1 kilogram is not going to be, it's going to be the same in Mars, Jupiter, everywhere, on Moon, everything. But the thing is changing is the local gravity. If I weigh here 120 kilogram on Earth, I'm going to be 20 kilograms on. It doesn't mean my mass is changing. Acceleration to the gravity, due to gravity is changing. So one day I remember I was thinking about Albert Einstein. I came up with this fantastic idea that how could I prove that, in a space, it doesn't matter any given time. It's called inertial mass and gravitational mass. Now I'm talking to you, I have gravitational mass because I am exactly 80 kilograms and the Earth is pushing on me 80 kilograms. I don't feel it, but I can feel I'm standing because they balance each other. But when I'm in space station, I don't have gravitational mass, I have inertial mass. But Albert Einstein did this one so good. He explained real good. It was so scientific. He said, in a given space, in a space, gravitational and inertial masses are different. They are identical. There is no way you can distinguish between which one is gravitational, which one is, inertial masses. I said, why not? If you invent your own pendulum, it might solve the problem. I show you here what happened. Well, of course, this is not as good as it was in year 2000, but it shows the principle. So what I did, this is the normal pendulum, but I had to have extension spring here. The reason why I knew what here is the maximum gravitational potential energy. And my spring is fully extended, see, otherwise, This is almost like 10 centimeters, but here's almost like 20, 25 centimeters. Here it has a lot of gravitational mass because it's toward the center of the Earth. But when it comes here, it also has gravitational mass, and then comes here, kinetic energy back and forth, back and forth. And then to my surprise, when this comes over here, for the momentarily, fraction of a second, this is retracted. And that was amazing inspiration for me. When this spring is retracted, I know that there is no force on this. So here it says gravitational mass is converting to inertial mass, and inertial mass to gravitational. At the same time, it's continuous because it's got potential energy and goes to kinetic energy. So I release this so you can see, well, of course this spring is a little bit strong, but it shows the concept. See what happened? When it gets over here, momentarily, it's changing from kinetic energy to gravitational potential energy and continuous. But I have to maybe swing it a little bit more. Oops. I have to swing this a little bit more so you can see. See what happened? When it comes here, retracted, see? See? Retracted there, retracted here, retracted there, see? See what happened? And this proves that, over here, when this spring is retracted, there is no force on this. And this proves that Albert Einstein was good on the principle of equivalence. But I'm hoping that you guys notice something strange here. When this goes back and forth, you see what happened? Earth is rotating. But this is not rotating with the Earth. It's just suspended in space. And you can see the plane is changing. The reason why Foucault did this, see, now it's going oblique. The reason why Earth is rotating and Coriolis forces comes in effect. I have the last one. This was unfortunately so controversial, and then most university professors, of course not all of them, some of them disagreed, but those who agreed, and that was great inspiration for me. Okay. This is very good experiment, and I want you to pay attention exactly what is happening. This one also took more than 6-7 months because I had to do so many experiments, and then I had to go to a factory and then buy brand new ball bearing. Why did I do this? Because ball bearing is made in factory, and if I buy marble, it's not going to work because the concentration of the mass is not same in marble. If I buy a stone, it's not going to be the same. But the factory does it for ball bearings. Because the big ball bearings, they're so expensive anyway. I had to buy those, and then I realized that I can do that. So I had like 32 grams versus 16 grams versus 32 grams. I suspended with thread like this, not thick like this, and then I realized that 16 grams is going exactly in 25 seconds, 1,000 RPM, and the 32 grams in 50 seconds is going 1,000 RPM. I was not happy with it. I said I have to try with the bowling ball. And imagine this bowling ball is exactly 6 pounds or 2.79 kilograms. When I suspend this, it's going to go so slow. And then I realized that proportionality is it's inversely proportional to the mass. More mass, less acceleration. Most university professors said, well, that has to do with unwinding this thread. I said, no way. Unwinding for 16 grams is acceptable, but not. I have also another one that's 7 kilograms, but not for 6 pounds or 2.7 kilograms. I said, well, how? How could you prove that? I said, because you need 60 at least or 70 Newton force to accelerate this. How could a thread like this do this? I said, well, what do you call this one? I said, yeah, we call this differential forces. And there was one Austrian physicist, he did it, and it worked. And the reason why in northern hemisphere we suspend anything, it can be apple, it can be bowling ball, it can be anything, it can be water bottle, whatever, it's going to rotate counterclockwise. That's why the cyclotrons are northern hemisphere is always counterclockwise, southern hemisphere is clockwise. I had to ask my friend in Bolivia to do that. He said, yeah, it is going clockwise, but in northern hemisphere is going counterclockwise. So I show you in a minute what I mean. I had to buy a tachometer, and that was electronic tachometer. Oh, I have to take this off. I'm sorry. I was wondering why it's not. See, if you pay attention here, see, I have to make sure it doesn't wobble or anything. It takes exactly 9 seconds to go counterclockwise, see? 9 seconds exactly. Did you see what happened? But something else comes in equation. Kinetic energy picks up. So I don't want to do this. Now, see, you can see it rotates. And then they were convinced, but a little bit skeptical. They said, well, I think there's no way that, this thread can rotate this. And then I had to rotate that 7 kilogram. That goes 15 seconds. Anyway, I had an argument with one professor. He said, Juan, how could you prove this? If you go back on my theories, especially I want you to watch the last page of the theory of attraction. This was, I would say, breakthrough in science. I had to use wire instead of the thread, and I bought one rod. It was heavy rod, almost like 10 feet, and then I had to do it in our company, which was a huge warehouse. And then I realized even Earth is causing torque on that 10 feet. But guess what? I could only go, I would say 280 degrees because, that's as far as it could go because the wire was thick. But I proved my point that, even though if it's not like a thread, the wire will do that. And then they love that idea. But what I want you to do, go ahead and watch my theories, and then you can see if I'm qualified. I can speak in your university. You can email me because, like I said, this is just a little bit highlights of everything, and I'm hoping that it will work. And then whenever I come to your college, the student can learn a lot because I have so many experiments because I couldn't do it. Like I said, it's 20 hours. My main objective was to activate the sense of wonder for a student, and then this is the way I was born. Always I remember, I analyze things. So I want you to analyze things. Anytime you have a question or anything, you can come to me or you can email me. So I appreciate you guys are watching these videos, and then I'm hoping you guys can subscribe, and then if you have any questions, email me, and I'll be happy to answer. And like I said, I have 40 more theories, and then I will upload them every week probably. And these are going to be also unique experiments I have never seen in any books, and you will enjoy them because it is not like normal. Most of them are counterintuitive. It's not like ordinary things. So thank you very much for watching, and then I'm hoping to hear about you guys soon. Thanks a lot.